Okay, hello, I'm Jonathan Lavelle, and I'm the project lead for the new Eclipse Amlen project, and I'm going to give you a bit of an introduction today about the project. As you'll see during the talk, it's an exciting time for Amlen, and quite a lot will change between the time that I'm talking to you now in early October and when you see this presentation, but we'll talk a little bit about that in the Q&A. Let me rewind a little bit and we'll get to that in a sec. So for some time now, the IoT space has been growing dramatically. There's about 30 billion devices connected to the internet at the moment, and that's projected to rise rapidly. And I should explain, I work for IBM, and IBM has been producing things in the IoT space for a long time. We've been seeing that the deployments of IoT fleets of devices have been growing in size and complexity. And some time ago, we released a product called Message Site, which was then renamed Message Gateway, and that now we would like to, or have open sourced as Eclipse Amlen. So let me talk a little bit about what Message Gateway was for, and then we'll get on and talk about Amlen. So Message Gateway was designed to make it easy to connect lots of devices out in the field, outside the enterprise, with applications running in the cloud or in a data center. So bidirectional communication had to be reliable and simple and secure. And it was designed so that you could start off with small prototype deployments, but scale up to very large numbers of devices, of the hundreds of thousands or millions of devices. And we will see that we have based this on a protocol called MQTT, which is an efficient protocol for transmitting IoT data on the wire. And Amlen also, therefore, is now an MQTT broker. In some sense, we are a little baby. Amlen's just being born. The code was open sourced as I speak in October the 5th, this morning. But we're building on this mature, stable, production-ready foundation of Message Gateway. So we have this sort of dual existence. We're just open sourcing the code. We're just getting our build infrastructure set up. But the code itself is mature, production-ready, and has been used in production for a long time. So we expect very quickly to get to a stage where you'll be able to use Amlen in production situations. I should just mention that the name Amlen, it comes from the Welsh word for envelope, and we think it's a good name for a message broker because it protects your messages between the sender and the receiver. So let's talk a little bit about the history. In 2013, IBM launched this message site, and it was a physical box, a hardware appliance that you connected into a data center, and it had a lot of custom hardware. In particular, it had some blazingly fast for the time non-volatile RAM that meant that messages, even persistent messages, could go through it very quickly. And that was great, but we found that as the marketplace was moving towards the cloud, customers didn't want this hardware so much. They wanted software. So IBM came up with version 2 of this product, which was a software equivalent that is effectively the thing that has evolved into Amlen today, so that it's now a piece of normal software that you install either in the data center or on a cloud somewhere. We find that it's often used for both traditional IoT type use cases, and we'll talk about a few of those, but also slightly less traditional use cases that you wouldn't necessarily think of as IoT. So, for example, it's often used with smartphone applications and web browsers. And if you look at this picture here, you'll also notice that I've got 2 copies of Amlen in the middle of the picture, and that's quite common. You often find that Amlen is deployed in pairs, highly available pairs. So if one server goes down, then you can still talk to your devices, and your devices can still talk back to the enterprise using the secondary, the standby server that will have taken over to ensure that uptime is not in any way compromised. So let's just talk about a few different use cases where we've seen Message Gateway used, and therefore I expect to see Amlen used in the future. So we have a lot of customers in the automotive industry and the car industry. So in two very distinct, different use cases. So it's used to communicate from cars back up to the manufacturer. So this is cars talking the MQTT protocol over cell phone, over mobile phone links. And therefore it's the car is in some sense the IoT device. Separately to that, we see it used in car manufacturing. So you have lots of big, expensive equipment and machinery that's used in assembling cars, and a lot of this machinery can be connected up to an MQTT broker like Amlen, and that way the factory floor can be monitored and controlled using MQTT. And so in some sense, I think of that as a fairly traditional use case, but maybe mobile phone apps are less so in the IoT space. So we have banks and airlines who have smart apps for smartphones, so Android or iOS usually, and or effectively web apps. That means that they can give an app to a customer, and then rather than, for example, sending a push notification to your customer's smartphone with sensitive details like bank balances, you can have an app that creates an MQTT connection that then has secure encrypted data flow to it from the bank to the smartphone application, where you can then have things like bank balances and things sent. We've also used in places like garage door openers, where you would like to be able to control the garage door from a smartphone. So this combines the smartphone use case with the sort of IoT device in the case of the garage door opener. And this means you can open your garage door even at a long range. So for example, not just when you're trying to park your car in it, but you can also open it to let a delivery person in to deliver a package. And then you have things like white goods, kitchen appliances, and lifts are common places where we're used. So if you think about a smart washing machine, people think that the main use case tends to be that the end customer can then monitor the washing machine, check to see whether the load is finished using a smartphone app. And of course, that's a valid thing that people do. But an important use case that people sometimes overlook is that you can get a lot of diagnostics from your washing machine. So if it breaks down and the customer wants it repaired under warranty, then you can have a good idea of what's gone wrong before the person with the van has turned up, and they're going to have the right parts on the van and hopefully fix that appliance quicker and have the end user feeling satisfied and a lower cost for the manufacturer because they have to make fewer visits because they have the right parts first time. So I mentioned Linux software, but I didn't really go into any more detail on that. So Message Gateway was sold as Linux RPM. So that's software that's normally installed on CentOS or more usually Red Hat Linux, Red Hat 7 or so forth. We will initially ensure that Amlen works in the same place, but we expect it to be packaged for other Linux distributions fairly quickly. Certainly, I personally am going to volunteer to package it for the Fedora Linux distribution, and I hope that now there's no cost involved and it's an open source license, we'll be able to get at least the server component into a number of Linux distributions. It's often run inside a container. It comes with an example Docker file so that you can install it into clouds. It's commonly run in Kubernetes and OpenShift, but it doesn't have to be. Many of our customers do run it in straight onto virtual machines or onto bare metal servers. These are also common. It works in both cases. So far, I've mostly talked about the server component, which is probably the most important component of Amlen itself. So this is the message broker that the messages are flowing through. But there are other components to Amlen, and probably the next most important is the user interface, the web UI. So this is actually a separate program that you can install in the same container and run on the same server, but you can also install it separately and then control a number of servers from one web dashboard. This is actually, as you can see in the top left of this screenshot, an old screenshot from Message Gateway, but at the end of this presentation I will do a demo and show you the current Amlen version. And so this web UI, as you'll see in the demo, you're able to monitor the system and see what's happening and drill down to individual subscriptions and things, but you're also able to configure it and control security permissions and things like that. So I should mention the Maximo application suite. So why am I talking about a different product? IBM is deciding to open source the source code to Message Gateway, which has now become Amlen. And the reason that IBM is doing that is because they are planning to compete higher in what they see as the stack. So IBM has a suite of products called Maximo Application Suite that allow you to analyze primarily data from large fleets of IoT devices so that you can predict, for example, which devices are likely to require maintenance before they break. And for this suite of applications, the Amlen technology is an important component effectively under the covers. So IBM is not walking away from this technology. IBM is going to use it, already does use it as a component in a number of IBM products. And therefore, we think that IBM and the rest of the world will get value as we try and build a community around Amlen and take it forward and give it a vibrant future. It will help IBM's products in this space. So now I've briefly told you what Amlen is for. You know, it's an MQTT server that allows you to connect IoT devices up to backend applications. I just want to talk fairly briefly about a couple of the key features of Amlen, and one of them is this HA pairs that I've already mentioned. So when you're having a messaging system like this, uptime is very important, and so you often have Amlen deployed in pairs, and then if you want to do maintenance on the main primary server, you can take the primary down and the secondary will take over. We have done a lot of work on HA pairs inside Amlen to ensure that the latency between them on the network can be larger than you might expect. So commonly, the message gateway or the Amlen pairs are split across availability zones in a public cloud. But when we test this feature, we often test with one of the servers in North America and another server in the UK. And as we increase the latency between the two servers, then that does increase the latency of messages going through the system. But the throughput still stays high. So this is a very common deployment of Amlen. And most production systems tend to be deployed in pairs. I perhaps also can mention that effectively the load balance in front of this pair can act as a tiebreaker. So if you have these two systems and they can no longer speak to each other, then you can configure Amlen so that the one that still has all the connections from the load balancer is the system that is the source of truth. And when the network split heals itself, you don't have a split brain that a human has to adjudicate. You have a system that the source of truth was the server that had the connections during the network split. I've talked about highly available pairs. You can also have clusters of Amlen. So whereas pairs were for reliability, clustering is for scalability. So if you have more devices, and you'll see that that's a lot of devices, then can be used on a single Amlen server, you might make a series of Amlen servers and connect them together in a cluster. So this means that if a device subscribes to one Amlen broker, then messages published on other brokers in the cluster are routed through the cluster and can can be delivered to that device. It's sort of effectively a shared topic space across all the servers in the cluster. People sometimes misuse clusters. They confuse the clusters with the highly available pairs I've already mentioned. We try and send as little data as possible around the cluster, so they're not a replacement for highly available pairs. If you want to keep all the messages and ensure that they're available for a device to come and collect, then you need pairs of servers. You quite often have in a cluster of pairs of Amlen. It's not clusters are for scalability, and highly available pairs are for reliability. They're not effectively a replacement one for the other. We also find sometimes when I'm talking to customers, I actually advise them not to use clusters, and that might be surprising, but the logic goes that this link on this picture here between the two clusters can sometimes be a bottleneck, and so you want ideally to partition your messages to go through the individual Amlen nodes, not between them. And for some use cases that's easier than others, and if you can partition your data like that, then you know that no data is flowing across the cluster link. If you don't set up a cluster at all, if you don't have clusters, then you know that you can just cookie cutter, replicate the server, and add more and more servers if you can partition your devices separately like that. If you were to build some kind of chat software where every device, for example, could talk to every other device, then a cluster, that would be a very good use case for a cluster, because any device in the cluster would need to be able to send and receive messages to any other device. But if you can divide your IoT fleet into partitions that fit on a single server, sometimes therefore you don't need a cluster, and you can be more confident about the scalability if you don't use it. So I've talked about the server component. I've talked about the web UI component that allows you to monitor and control it. There are also other components, and the key ones here are for bridging between Amlen and other servers. So you have actually a number of bridges that come with Amlen. You can connect Amlen via a bridge to other MQTT servers or to Amlen itself. So you can build a network, a hierarchy of Amlen servers that some topics are replicated around the hierarchy and others aren't. And you can also have messages that arrive at the Amlen server forwarded onto Kafka, so that you can use Kafka as a sort of effectively a fat pipe to receive all the messages through your system if you need to do that through Kafka. And you can also do bidirectional communication with a messaging broker called IBM MQ, if you're familiar with that. These bridges allow topic strings to be rewritten as the message flows across the bridge, and MQTT version 5 has a feature called message properties, which is effectively metadata that flows with messages, and these bridges allow filtering, so as messages go across this bridge, the messages can be filtered based on the metadata that flows with the message. So I've mentioned before that Amlen has had a focus on performance, and it shows. You often can have hundreds of thousands of devices connected to a single instance, and single instances can do hundreds of thousands of messages a second. You can, on big instances, have millions of devices and even millions of messages a second, but we often recommend against that and suggest slightly smaller than instances in the sort of hundreds of thousands of messages a second, or hundreds of thousands of concurrent connection range. So I mentioned already in this talk that at the time of recording, we open sourced the code for this morning. So as I speak, there are no builds of Amlen available publicly, and we have a lot to do. So the first step is going to be to get builds that people can download and use, and then once people can use it, we need to make it easy for them to use it. So as part of the long legal review we've been going through that has determined when we've open sourced the code, we've also got our documentation through that process, and now we can set up a website with all the docs for Amlen. And we can start to make on-ramps for contributors. We can write guides for how to develop Amlen in the future, as well as then to start adding more features to Amlen. So in particular, we think a Kubernetes operator that allows Amlen to be even more easily deployed into Kubernetes would be a good thing, but also more plugin APIs. And there is already a very bare bones code for an MQTT proxy that would sit between a load balancer and the server, and we would like to extend that and build that proxy into something that's more useful. So we need help. We need lots of help from anybody who's prepared to give it. We need help from people who can help us with our website. You could write guides to help people get started with using the features. And we also need programmers to add exciting new features, but to also fix bugs and write tests. And I've mentioned already that we'd like to have it packaged for as many distributions as we can get. I'll just show these links here. There's lots of ways to get information about Amlen. If you just remember the top one, eclipse.org/Amlen, then there are links to the others, our Slack channels and our mailing lists from there. So the key place to get information about Amlen is eclipse.org/Amlen. So I'm almost out of time, but I do want to do a very quick demo before I end. So let me swap now to the demo. So I'm now going to share a different window, which is that one. Lovely. So what we're going to do now is effectively have 3 different MQTT clients, IoT devices emulated in a web browser. And what we're going to do here is have a whiteboard. So if I draw on one of these whiteboards, you can see it's replicated to the other whiteboards. And these are going through the messages going up to the server and back again. And as you can see, it's useful for very low latency connections. And you can also see that I'm not very good at drawing on a whiteboard with a mouse. But if I was doing this demonstration in person, I would get members of the audience to have each of these whiteboards on a mobile phone. But as we are doing this via video conference, you'll just have to trust me that these 3 different windows in this web browser are 3 separate MQTT clients. In fact, if I log into the web UI, you can see that when I reloaded the page at the start of the demo, we had 3 new connections come into the server, and you can see that we've had lots of messages come in and out, and you can scroll down and get lots of information about the system, and you can also go and look at individual subscriptions. So each of those 3 whiteboards that we can see had a separate subscription, and I've published 500 roughly messages to each one. And in a real system with hundreds of thousands or millions of subscriptions, you can filter subscriptions to, example, find the ones that have the most messages expired. So if they're not being collected quickly enough, you can go and drill down and find subscriptions and clients that are causing problems. And you can also obviously filter by things like topic string and the ID of the client. So as well as being able to monitor, you can also control. So we can configure, for example, which topics you can publish and subscribe on. So I could, for example, add a rule called mailbox that said that anybody in the group mailbox was allowed to subscribe to the topic. I don't know, /mail/user ID. So what I'm doing here is basically adding a single rule that says anybody has a private topic that they can subscribe on to receive their mail. And just with this one rule, anybody in this group gets a mailbox like this. Every time we add a new device to the system, we don't need to come back in here and add more rules. It's just a policy that applies to all the devices that we want it to apply to. And you can also set things like an expiry time. So if the messages aren't picked up quickly, the server can throw them away rather than have it clog the server up. And we can set how many messages we buffer. Okay, I'm running close to my time now, so I will end the demo there, and I will hand over to the live version of me to ask if there are any questions that you have about what you've seen in this talk, or any other Amlen related questions. Hi. So what I'm going to do now is go through some of the questions that have been asked in the in the chat. But before I do that, I just want to say that since that was recorded, we now do have the first builds of Amlen live. So you can now go to the website eclipse.org/Amlen, and you'll be able to find a link to download a very early build that has now been produced of the Amlen server. So let me answer a few of the questions that have been asked in the chat. So the first question is, will IBM continue to offer commercial products based on Amlen? And yes, we will. The key one that's available at the moment, I did mention in the talk, is called Maximo Application Suite, which is a suite of applications for managing fleets of IoT devices and analyzing the data from them. And there will be others. I was asked whether there would be support for the Xeno protocol or other protocols like CoAP, and currently Amlen supports MQTT version 3, version 5, and JMS 1.1. It has the ability to be extended for other protocols. You can write plugins to do other protocols, but I don't think there's a Xeno plugin available. I'm asked whether fault tolerance is only available in pairs, or whether other configurations are possible. And HA pairs is the normal way that we would recommend customers to use fault tolerance, the thing we'd use for fault tolerance. You can have message gateway clusters as well, and in some cases, if for some use cases, you can use a cluster of message gateways for fault tolerance, but the normal configuration that would apply to most use cases is the HA server. What else have I been asked? So I'm asked about my vision of gateways. So as somebody who works on the server side, I'm going to stay a little bit agnostic on that question. Eclipse has a project called Cura that is designed to help with IoT gateways, and there are lots of IoT gateway projects, but Amlen is not usually used as a gateway. Lighter weight things like Mosquito are sometimes used in the gateway role. So I'm going to have some strategic ambiguity and not really answer the question about gateways. There is a question about plans for a Helm chart, and Kubernetes support is important to us. We definitely are going to be looking at how we can best support Kubernetes. I'm thinking that the best way to do that is an operator that we've started to look at, but Helm charts would be good too.